So, super important, whenever I star something, was it last chapter you wrote the starred problems or the chapter before? I don't know. I'm not going to have you write them anymore, but I want you to know it means focus on these. Is my hair sticking up funny or something? Funny. All right. So I'm going to fill this in. Absolute value. You guys are funny. If you're listening to the recording, I forgot to turn it on, so you're getting us mid-swing, but it's better than nothing. Right, kids? Sure. So we'll say this. Our speed is equal to the absolute value of our velocity. Now the next thing is very important. It gets asked a lot. They'll talk about when speed is increasing. With a graph, which we'll talk about tomorrow, that's easy. Without a graph, when we just have models, here's what has to happen. I want you to write speed, and I'll show you on the next page how to figure it out. But they'll ask you, at what time was the particle's speed increasing? Speed is increasing when? First of all, it's not about velocity or about acceleration. It's about both of them together. They have to be working together. So I have to be going forward with a positive velocity and be putting the pedal to the metal and having a positive acceleration for my speed to increase. Does that make sense? I call it gunning it forward. So it's when V of t and A of t, acceleration and velocity, have the same sign. So I'm just going to go plus, plus, or could you have your speed increasing if you are going in reverse in your car? Yes. So not only gunning it forward will increase your speed, but I call it gunning it in reverse. For some kids, they don't get how a negative acceleration can cause you to speed up. So let's take Paige. She walked in late. I'm angry. She disrupted us. So I'm going to take her out there and I'm going to put her on top of the building. I'm going to push her off. Yeah, yes, sir. It's very violent in here. Anyway, I push her off, right? As she falls, will her speed increase? Definitely. Her velocity is negative because she's going down. Her acceleration is negative. Why? Acceleration due to gravity. Negative 9.8 meters per second squared or negative 32 feet per second squared. But you can't deny she's going to go faster and faster and faster, correct? Yet both are negative. So we do sign analysis, but we have to have these two working together. Go ahead and write speed dec when. So when is your speed decreasing? If I can read a graph, that's a piece of cake. But when I can't, I have to analyze the functions with some algebra. So now I'm back in my car. All right, think of my speed decreasing. I'm coming up to a stop sign. My velocity is positive because I'm going forward or away from my original destination. So coming up to a stop sign with a velocity, correct? But I'm putting the brakes on, which causes my acceleration to be negative. So they work against each other, and what do? Slow down. Does that make sense? Now before I move on, because this is what was causing an issue this morning on the one we're going to do, the concept of acceleration messes with people's heads. Because right now, what's my velocity? I'm going to stand up. What's my velocity? However, my acceleration is not 0. You might say, what? I am accelerating. I'm accelerating towards the floor, but the floor is stopping me from moving. How fast am I accelerating right now? Yes, gravity. If I wasn't accelerating, I'd be floating around out there. So just because you're stopped, does that mean you have no acceleration? No. So you got to be careful with that. Here's another thing. Because you have no acceleration, think about what I said, does that mean you're stopped? No. You can be going very fast. You could get ticketed, right? If you've set your cruise at 80, right? Your velocity will be 0, change in velocity, or your acceleration is going to be 0, correct? But you're definitely not stopped. And the last question. Suppose your velocity is negative, but your acceleration is 0. You're going to have to interpret that. Here's your 4 options. So think about what I said. You have a negative velocity. Make sure you have a concept of what that means. And 0 acceleration. Here's your options on today's worksheet. Is your speed increasing, decreasing, constant or are you stopped? Constant. Exactly. I'm going backwards at the same speed the whole time. All right, so that just caused some issues on one part of the worksheet. So we're going to do this problem in full. It's starred. Here's why it's starred. Read the bottom. It says, this is so important. I'll read it. I'll read to you, okay, Blake? It's a bedtime story. Once upon a time, there was a starred problem. It was so important that tomorrow he got a quiz. It's actually not a quiz. It's test points, 9 of them, all right, on it. But Mrs. LaRude was so nice and smiley and gave out lollipops, and she put the actual problem on the next page. But she does have an evil streak. She did not do it for everybody, but I did record it. So you might want to write recorded. I will give you this exact same model tomorrow. So if I go through this one and Paige is like, I get it. I was like right ahead of her the whole time. Do not watch that video. You'll be fine. All I do is change the position model and ask you really similar questions. But on your test tomorrow, I will give you this exact same position. So there's really no reason that everyone shouldn't get 9 out of 9. But do you think I've ever had 9 out of 9 for everybody? No, because people think they know it, or they just are too lazy and they don't want to watch it. You guys have been pretty good with that, though. But, so I'm going to go through this. And again, if Clausen's like, this is my strength, I totally get all these. Don't watch it. It'd be a waste of your time. But it's for those out there because most of you, about half will get it and half won't. I don't want to go through a whole nother one for the half who get it. All right, so I try to do that. We'll go do this one nice and slowly. If you're like, I got it, then don't worry, don't watch the video. So I will give you a position model similar to but different than this one. I will ask you either, when does it change directions, or I might change it to when's the particle stopped or when's the particle at rest, but they all involve doing the same math. For something to change directions, what must it instantaneously do? Stop. And if it stops, what must I set? What equal to 0? I'm hearing different things, and I can't really hear very well, so I'm not quite sure. What's 0 when you're stopped? Velocity. Okay, does that mean I necessarily change directions, though? If it just said stopped, I'm just saying, where's v of t equal to 0? If it just says at rest, v of t equal to 0. But if it says change directions, I have to make sure I didn't stop and keep going forward. So what do I have to make sure my velocity does? Change sign. All right, so this is what I'm looking for. How do I do that when I can't see a graph of it? I actually go write a model for the velocity. I take the derivative of my position. If you're like, yeah, I would have known to do that, then so far you're good to go, right? Or if you just listen super carefully, you might not have to watch. All right, so actually this is most important for the people gone right now, because you guys all seen it once at least. Now, if I have you do it without a calculator, I'll be nice. My goal is not to have icky math in here. It's conceptual. I want to make sure you understand the motion, so it will factor, and it's going to factor beautifully. Otherwise, I'd let you use a calculator. So my velocity model is actually 3 times t minus 1 times t minus 7. What do I know for sure right now? The particle definitely stopped when? 1 second in, 7 seconds in, but I'm not convinced it changed directions. So you need, because you might get one sometime where it goes positive, 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 negative, and there was only one direction change with 4 zeros. So you have to actually go check. You go and you make what I call a sign line, and we're going to chart the movement or the velocity, not the position. All right? On your sign line, we don't go negative for time. That's why I blocked it off there. You put your zeros on, 1 and 7. I'm 100% sure I stopped at those times. Then what I do is I test to see what's happening in the other intervals. By the way, it shouldn't bug you that this has to either all be positive or all be negative. Can somebody tell me why? If I just figure out what it's doing at one spot in there, I get the entire interval for free. Yeah. Yeah, he's kind of talking about a visual intermediate value theorem. Because if I found the zeros, And somewhere in here, it also went from positive to negative. It wasn't the same. It would have had to pass through 0, correct? So whatever happens in here happens on the entire interval. So what we do is we just pick our favorite number in the interval. I'll make it a half, and we want a sign test. Don't put it in here. Don't put it in here. Put it in here, and don't even write anything down. Go positive, negative, negative. Boom. What does that mean I was doing for the first second? Going forward the whole time, or up, but did this say the movement? It's moving along the x-axis, so to the right actually would be the best way to say that. Next, run a quick test on your favorite number in that interval. Let's call it maybe 5. It'll go positive, positive, negative. Boom. That was definitely a direction change. And then last up, pick your favorite number on out to infinity, maybe 11. Positive, positive, positive. Any questions on how I made the sign line? Do not leave that. I was actually a reader last year for a particle motion question, and in our briefing, we get briefed for like 2 hours before we actually start reading, and then you read the same question for close to 2 to 3 days. And then once that question's done, they brief you on another one, right? They said you must be sign line blind. That's what they said. They said you don't look at their sign line. They're in charge of telling you what their sign line means. So now I have to answer the question. What's the answer to the question? At what? Yep, and let's say this is in seconds. So at t equals 1 second and what? Go ahead. Yep, whenever I put the headset on, you guys stop talking. Just pretend I'm not wearing them. They can't hear you in here. But if I said justify, you'd need to add to that. You would have to tell me why you chose those. You wouldn't assume I'd look at the sign line, because I don't. You're instructed, don't even look at it. You'd have to say, because this is where, what? There's a sign change in velocity, or this is where velocity changes sign, or you could say goes from positive, negative, vice versa, all that kind of stuff. Mine did not say justify, and I answered the question, so I'm done. I don't need any more work for B. Somebody read B. Raise your hand and just tell, what is it, Gunnar? 1 and 7. Yep, and you could use the words between 1 and 7. They prefer the interval notation. If you wanted to kind of make it look fancy, you could say t an element of. Now, it didn't say justify, so 100% credit. If it did, you'd say this is where, and you wouldn't say this is where it's moving to the left, because that's answering a question with the question. You'd say this is where velocity is. You're on fire today. Awesome. You brought your brain. So the next one is the most missed type. All right, so go star that sucker. Whenever I grade these, that average velocity question is the most missed. I'm going to give you the 2 answers I see. I see about 1/3 right, 1/3 do this. Don't do this. They find the velocity at 2 by plugging it in to their velocity model, find it at 1, add them up, and divide by what? That is not even close. That's the worst. Another third do this. V of 2 minus V of 1 over 2 minus 1. You might say that's what we're supposed to do. I'm like, no, you're not. Because this is feet per second, correct? This would be seconds. You will have found feet per second squared, also known as average. Yes, that's deadly. Super common, though. So when we're doing average velocity, our answer should be feet, which is position, over time. So what should you do? S of 2 minus S of 1 over 2 minus 1. Plug and chug. I'm not going to do it. I'm confident. Actually, on the video one, I actually did my arithmetic wrong. I was just going to say, I'm confident your arithmetic will be right. But somebody in Elk Time said, I think we're supposed to have a 17 instead of a 7. I'm like, yeah, whatever. I get bored with the arithmetic, so I get sloppy. Anyway, almost done. When it says, what is the velocity? Average or instantaneous? Instantaneous. So I need to plug it in, but I don't have my calculator. So the best place to plug it in is the factored version. Go put a 4 in here. 3 times 3 times negative 3. It's easy. Again, this is concepts. The math is so easy. But this would be negative 27. You could call it lots of stuff. You could call it V of 4. You could call it S prime of 4. Whatever, you could call it nothing because it doesn't say you have to. But let's label it feet per second. And the last question. I want to know when the thing was speeding up. What do I have to analyze? Position, velocity, acceleration, or a combination? What do you think, according to what I've said? Acceleration and velocity, exactly, Devin. Well, the velocity I've already analyzed, so let's just go put it back on here. I know it was this and this. That was my velocity sign line. It went like that. I already did it up above. I need to kind of compare it with the acceleration. Well, we haven't done that yet. How do you get acceleration? It is the derivative of velocity. Yeah, so let's go back up to the top and find the best place to go to take our derivative. Again, you got to use all this stuff without a calculator. So you're going to decide, do you want to take the derivative at level 3 that we've been using for all our arithmetic, at level 2 partially factored, or at the level 1? Level 1, power rule it. You got it, right? What's my acceleration? How about Lizzie? What would be my acceleration model if this is my velocity? They'll be easy. Yeah, the point isn't for Lizzie to take a hard derivative. The point is, does she understand particle motion, right? So yeah, quick, easy, 6t minus 24. Lizzie, are you entirely clear where that would be 0, or do you need to factor it? She's pretty clear, right? You need to figure out where it's 0. I'm going to put this was V, this was A. Right here at 4. By the way, that doesn't mean it's not moving, correct? So put a little 0 up there and then do the exact same thing you did with your velocity. Head to the left, quick plug, negative. Head to the right, quick plug, positive. Now, for the speed to be, it said what? Increasing. What's got to be true on your sign lines? Same sign. I feel like you're really getting it. Right away at the start of the motion, that thing's slowing up because acceleration's fighting velocity. It's going forward with the brakes on. Does that make sense? So you have to figure out where we either pedal to the metal forward or backwards. So give me one of the intervals. Somebody who hasn't talked yet today. How about Savannah? What's one of the intervals? 1, 2, 4. Yep. And open, although you don't get marked wrong if you close them because of like I've told you, kids make them so messy it's hard to tell what they are. Then there's another place also where we're speeding up. What interval? What do you say, Harvey? 7 to infinity. Perfect. That's the answer. All right, so we're done. We have 12 minutes and we're going to organize number 10 on here. When is this worksheet due, do you think? Monday. Tomorrow you're going to take a 5-minute one of these. It's going to be timed. I mean, if you know how to do it, this goes fast. Maybe a little more than 5 minutes. Then you're going to do a circuit, which you'll finish in class. All right, and the key to this, by the way, is in Schoology, totally worked out, and so is yesterday's homework. They're two kind of big assignments. This is a big section. I'd say top 5 of all sections we do. We're going to go organize number 10. So and then you can decide if you want to keep rolling or quit. But before you pack up for the day, we are going to take out a blank sheet of paper, and we're going to lay out how we're going to organize number 10, and then maybe you'll just want to finish it. So I'll let you guys find one. I think I have paper on my front desk too. And before I forget to tell you, you don't have to do the X'd off ones, not because they're too difficult, they just don't serve a purpose. I mean, number 2 is just like number 1. I don't like busy work. Thanks, Miss LaRue. You're welcome. Also, number 17 is an X'd off, but you don't have to do it. If you can figure that one out, I give extra. So you might want to circle. I always like to, for some of you who need an extra challenge, I'd like to offer that every once in a while with a specific problem or an elk time. That would be number 17 for this assignment. Don't have to do it though. You can quit at 16. So organizing number 10. They're giving you a position model and it says make a table. I want you to organize it like this. Your table needs to chart position, needs to chart velocity, it needs to chart speed, which is absolute value of velocity. It needs to chart acceleration. And then it also says at each of the times, so we're supposed to go 1, 2, 3, 4, 5 seconds, minutes, hours, it doesn't say. Specify direction of motion. So we're just going to pick one. Do you want this particle moving left, right, or up, down? Because I don't care, but let's just pick one. Left, right, or up, down? All right, so if it's going to be left, right, then when in this last column, I want you to write L or R for left or right. It also says, is the speed increasing, speeding up, slowing down, or neither? Okay, so over here, speeding up, let's do this. Speeding up, slowing down, or neither. And we'll go fill in a column. So now I'm going to go make, let's go. I'll give you some time here. This is fun. Didn't go. There. How's that? Is that good, Bo? It's all right. Not too bad. Let's just do second number 1 here. Did I give you guys enough time to fill it? I will never ask you to find the position at a specific time because it's plug and chug. But can you guys tell me the model? What is it? What's the position model given? T cubed? All right, let's go do the velocity model. Might as well. T squared, thank you. And since you're being so helpful, will you take the derivative of that for me? And since you're being super helpful, will you factor that for me? Awesome. Perfect. I don't have to think it out. Then will you please take the acceleration of it for me? See, I don't even have to think. And then can you please factor that for me? Awesome. There we go. We're all ready to roll. I'm going to run through the first column. What is the position at the first second? 1 minus 6. By the way, I will never ask you a question like that. That's pre-algebra, right? What's the velocity?